Alright, Cassidy, this is the problem you asked me about. And graphing polynomials is always a long process. So I'll kind of walk you through how I do these problems, and we'll go from there. The first thing to notice is what the degree of the polynomial is. In this case, the degree is 3, which is an odd number. So the degree is odd. The next thing to notice is that the leading coefficient there is a negative number, negative 1 in this case. What these two pieces of information combine to tell you is what the basic shape of the polynomial is going to look like. We call this the end behavior of the polynomial, and in this case, with a negative leading coefficient and an odd degree, the end behavior looks like this. What this just tells us is from left to right, the function goes from very high y values. We don't know what happens in the middle, but then as x increases, we know that the function is going to go down and have very negative y values. So we like to keep that in mind as we're doing this problem. The next step would be to find the zeros of the function, and the way that we're typically going to do this is we'll factor if possible. In this case, this polynomial can be factored. You can take an x squared, or in my case, I took a negative x squared out of each term. The reason that we factor is because if we want to find the zeros of a function, we just set the function equal to 0. And a factored polynomial we can split up into pieces. This first term tells us that x squared, or you could say negative x squared, equals 0. The second term tells us that x minus 2 equals 0. And we get two zeros, x equals 0 and x equals 2. So let's draw a quick graph of the information that we know so far. Okay, so far we know that x equals 0 is one place where the graph is going to cross the x-axis. Another place is x equals 2. Those are the two zeros of our function. So we're starting to get an idea of what this function might look like. We know that it's going to look something like this. So the function's going to come in like this, touch that 0, something's going to happen. We're not sure what happens in here yet. It's going to touch this 0, and then it's going to eventually go down to negative infinity. But we need more detail than that. So what we want to do is we want to pick some values for x to plug into our original function, so we can plot a couple of points along the way. So we're going to plot a few points. What would be some good x values to choose? Well, it looks like something in this region would make sense. So we're going to pick some x value between negative infinity and 0. The way that the book's going to say this to you is they're going to say pick an x value on this interval, negative infinity to 0. Well, an x value that would make sense would be a simple one, maybe x equals negative 1. Plug that x value into the function, and the notation for that looks like this right here. We get f of negative 1. We're just replacing x with a negative 1. And we end up getting negative 1 squared, negative 1 minus 2. And if you do that calculation, let's see, you get 1 times negative 3, but the whole thing is negative, so I think it's going to be positive 3. That gives you another point on the graph, the point negative 1, 3. So that would be this point right there. We can do this a couple more times. Another place where it would make sense to choose an x value would be between 0 and 2. So on the interval 0 to 2. What x value makes sense to choose? Well, the only one that makes a lot of sense is 1. X equals 1. And how do we find the y value? Well, as always, we plug that x that we chose into the function, and I'm getting a value of 1. So we have a point, 1, 1. I'll graph that. Let's choose one more x value over in this region somewhere. Let's pick an x between 2 and infinity. The interval is 2 to infinity. What x value makes sense? Well, I think 3 probably makes sense. We'll just choose the x value to be this one right here. And let's see what the y turns out to be. Do the math there and you get the point 3, negative 9, which if we go back to our graph, 1, 2, 3, and negative 9 is somewhere down here. Now this becomes an exercise in connecting the dots. So I'm going to start over here. I'm going to connect all these dots. We know that polynomials are smooth. So our graph is going to look something like that, which matches up with our original idea of what the end behavior was going to look like. So this whole thing kind of checks out for us. Okay, so I think that's it. All we did to review is first we thought about the end behavior. We kind of got an idea of what the graph might look like. We found zeros by factoring. We plotted those zeros. And then we picked a few more points to kind of give us a little bit more information about what the polynomial looks like. And that's it. Okay, I hope that helps you out. Let me know.